Today we'll learn about our last two types of congruence theorems, angle-side angle and angle-angle-side. The difference between the two is where the side is located. In angle-side angle, it is the included side between the two angles. In angle-angle-side, it is the side across from one of the two congruent angles. In our first example, we're going to look at, can the two triangles be proven congruent? If so, what congruence theorem would we use? Now remember, we're allowed to mark a common side and vertical angles, and that's it. So on this one we have a set of vertical angles, so this would be angle, angle, side. In the second example, we're allowed to mark a common side, and that's it. So not enough information, because I only have two sides that I can mark. And on the third one, we have a common side, so this would be angle, side, angle. Notice it's the side in between the two angles. Same way to prove these as the other problems. We're going to write our first given. AD is parallel to EC. Remember, when we have parallel, we're going to pick a pair of angles congruent from the picture. My parallel lines, we have to look what the parallel lines are. We have several options here. I'm going to use angle C and D as my alternate interior angles congruent. BD is congruent to BC is given. It's already marked on the picture, we don't need to mark it. We have vertical angles, so we'll mark those and write it down. Angle ABD is congruent to angle EBC, and those are vertical angles congruent. I have three parts marked on the drawing. I can go to my proof statement. ABD is congruent to triangle EBC, and it's angle, side, and angle. The side is in between the two angles, so it's angle, side, angle. In our next one, we have DH is parallel to FG, and that's given. I'm going to use angle D and angle G, and those are alternate interior angles congruent. Remember, anytime you have parallel, we're going to have either alternate interior or corresponding, and most of them are alternate interior angles congruent in our two column proofs. DE is congruent to EG, and that's given. We need a third part. We've got vertical angles once again. So angle DEH is congruent to angle GEF, and those are vertical angles congruent. Therefore, my two triangles are congruent. Triangle DEH is congruent to triangle GEF, and this would be angle side angle. I'll show you a different way that you can prove the two triangles congruent. If you wanted to, on this one, you could use both pairs of alternate interior angles rather than using the pair of vertical angles. Because we have parallel, we could technically use angle D and G and angle H and F. They're both alternate interior angles, so it would not be incorrect to use both of these pairs in a problem. So this is just a second way to look at the problem. And if I use that, and the next given, DE is congruent to EG, and that's given, then my congruence test would change to angle, angle, side. So triangle DEH is congruent to triangle GEF, and this is angle, angle, side congruence. So this set of triangles can be proven congruent in two different ways. Our last example is not asking us to prove anything, but we can look at the drawing just to see how you could prove the triangle is congruent. So again, I'll show you what's parallel to what. So we have FH is parallel to GK. If we have parallel lines, once again, if we use a pair of angles congruent, so angle FHG is congruent to angle KGH. Those again are alternate interior angles congruent. We already have the right angles congruent, and that's given to us in the picture. And then we have GH is congruent to itself, and that's the reflexive property. These two triangles would be congruent by angle, angle, side. So triangle FHG would be congruent to triangle KGH, and that would be angle, angle, side. The side is across from one of the angles. And that's all we have for today.